mean, that's extremely important. Don't wait at the last minute to do all of them at the same time. This will give you practice for the exams, and also this will help you understand the material. Sometimes this material can be very boring because this is called statistics. Sometimes it can be interesting, but most of the time it's going to be boring. So if you do study and work on the homework, that'll be very helpful to you. Okay. All right, then. Let me just start. Now we're gonna start going to chapter 3. Okay. So let me go to chapter 3. Hold on, give me a moment. Let me just turn on my slideshow. Okay. Okay, so this one here, we'll be talking about numerical summaries, so that such as numerical summaries, you mean like center. We're going to be talking about center again. You know, center, we talked about it before. It means either the mean or the median, the mode, and mid-range, etc. We're going to be talking about, today we're going to be mainly talking about the mean. Okay, so let me just show the screen. So we'll be talking about the mean mainly. Okay, right here. So give me one moment, please. Let me just get my screen set up here. Okay, so this is the definition for the mean. We do have a symbol that we use for the mean. I'll be talking about it later on. Okay. It will, first of all, let me just give you a quick idea before I go to the definition. We have two different types of symbol for the mean. For the mean, whenever I talk about the mean, if it's a population, if you're talking about the mean of a population with a specific symbol, it goes like this. Okay, you spell the way you read it is mu. It's said as mu. This one is for population. Okay. Okay, and then we use the symbol X bar like this. Just X bar, you read it as X bar. And then this is for a sample. A sample is like, you don't have to use the entire population, you just use the sample. This is very important because you're going to be talking about that, the one on top, this population in the future. But today we're going to be focused for a sample. So we say that the mean describe the center of something. Now, for example, if I have two weights and I put them in a bar, and then the mean will be like the one that make them to be not falling away. Okay, so that the mean will be something like this. That will be the mean right here. You hold them together, so it's like it balance them. That's why you call it the mean. That's why I say this is also a measure of center. It balances everything. It balances the data. Okay, so the mean will be a numerical value. Okay, it's like a sum of all the numbers. Also, the mean will represent a data set. Okay, that's why it's a summary. We say a numerical summary because it represent. I'm sorry, let me just put a better in writing thing here. We say a numerical summary because it represent. The set, okay, or the given set, okay. So just like we say, it's a balancing point for the distribution. It's like a number that is like a balancing point for distribution. That's why I call the mean. Okay, it can be used as a typical value for symmetry, mound shape. So if you have the mound shape like this, we talked about it earlier, something like that. See, the mean would be like something like this right here. That also can be the mean. The mean can also be the center for the mound shape. A typical value, it means something that it would be the most. Okay, remember that the typical value is the most common value in a set. Okay, we can just say this is the most common value in the set. Sometimes it can be the mean also. It depends. And the set. I said the set because this is given set. Okay, so then after that, there's something called standard deviation. They say the standard deviation describes the spread. What does that mean by describing the spread? It means that a standard deviation, in fact, this is the whole definition is the following thing. You're gonna say is how far let me just wait. Is how far okay, I can say how far each data value that's a V right here, falls away from the mean. So it's an average distance from each value to the mean. Okay, so you have to put this in the back of your head. That is like an average distance of each data value to the mean. Okay, or how far each data value falls away from the mean. Okay, whenever you're given the mean. So that thing is also going to be a numerical value. Okay, is also measure a typical distance from the, like that's why I was saying, say whenever you say measure a typical distance of the observation from the mean, that means how far each value is far away from the mean. Okay, so he also gives you an idea of something called variability. He give you like what I mean by, you talk about variability before, is like the way the data is spread. It can be like you can have high variability, you can have low variability. You have high variability if you have a bunch of observation. But before we keep going, there are two things also I wanted to point out about the standard deviation. I'm gonna write it down over here. For the standard deviation, we do have a symbol for it as well. For the standard, let me just put S and then T, standard deviation, SD for standard deviation. We use the symbol something like this, like overlay that thing on top. It's called sigma. It's a sigma if you use a population. If you talk about population of a population, I mean, if you talk about this, the standard deviation of a population, you're gonna say sigma. Okay, then we use the letter S for a sample. Just remember that because we'll be talking about those things in the future. We use the symbol sigma. Let me just make it a bit nicer for population. If you're talking about population, you will use sigma. If you're talking about a sample, we use S. I mean, it's lowercase s, okay? Any questions so far? Make sure I got my chat on. No question. Thank you very much. And then let's see. So it's very good to remember these little symbols, because we will be talking about them so many times in the future. Okay. It also to understand the idea behind what you call the mean. Okay, and also they understand the idea behind what you call the standard deviation. Again, the standard deviation is how far each data value falls away from the mean. Or you can say measure is a measure of is a typical distance of the observations from the mean. Okay, so that's why we can talk about them. Let's look at a couple of things here. This is a data that is given to you, but now you are given the histogram. Okay, if you have to, suppose you put this on a scale, if you have to balance it, apparently you're gonna have to move the scale just a little bit down below 5. I want here, something like that, to balance the data. Suppose you put balance the data. That's why the mean, that's why I call a mean, just like we said earlier. Okay, if I put everything in a scale, then you have to put something to balance the data, and then you're gonna have to put the scale right here, kind of in between there. Okay, so one of the reasons is that here you can see the typical value right here is over there, which is the most common value. Is some number close to 0. Okay, which are about 400 of them. So that's what you call the mean, in fact. Okay, that's what I call the mean. So if you have outliers, that outlier will try to drag the mean toward him. Outliers will drag the means. Okay. Okay. So that's why it's very important to know if an outlier can be an error or can be something like that. Okay. So it's very important to understand that. So if you have outliers, it will drag the mean toward it. This is an outlier right here. As you can see, that is very single out all the way on the right side, which created like what you call a wide skewed. As you can see, this is like, this one has a shape of a wide skewed, something like this. Okay, so this is right skewed. Okay, the presence of the outlier make it right skewed anyway. All right then, so okay, that's what I was talking earlier about. So for right skew, what is on the mean is to the right of the typical value. In fact, this is the typical value right here. The one that will put the most, the mean is on the right side. This is what the mean is on the right side of the typical value. Okay. Again, typical value, just as I said earlier, is the number that will put the most in a set. The one that is the most common. Okay. If you have the symmetric distribution, the mean will be like close to the center. Okay, close to the center. It's like you put everything in a scale. The mean is like close to the center to balance everything. And then that's again, so to give you an idea of what a mean is. It does balance the entire thing on a scale. Okay. Let's see. I'm gonna have to use a different from where we go back to OneNote. But let me use this one for now, see what happens on a scale. Okay, So that's why we are balanced on a scale. So the mean is going to be balanced and everything on a scale. All right. This is for bear shape. This one kind of barely have a bear shape like this. As you can see, goes up and then go down. Something like that. And here we go. Okay. So the formula we use for the mean is very important. Also, what you need to memorize it. You don't have to memorize it by heart, but I mean, put it in your little notes. This is the formula we use for it. This is one. What does this one mean? It means that this is S bar is the symbol that we use for the mean. It means add all these symbols mean add all the data value. You need to add all of them. Okay. Then that symbol that bar means is divide. Then divided by, okay, by n will be the number of values. So I'm gonna put the notes instead, so probably kind of closer. Okay, and we mentioned the sample size. Okay, and we mentioned the sample size. What I mean by size is a number of data value. Okay, I'm going to put value of S is a number of data values, number and the set. I'm going to give an example soon. This is very simple now. Okay, and we present the sample mean. We measure, like I said earlier, the X bar will present the mean for a sample. Okay, this is an example that I give you. They say to find the mean of this specific data, which is 3, 2, 2, 1, 2, 3, something like that. Okay. So we need to find the mean for that. So how do I get the mean for it? So what I'm going to be doing, I'm going to add all of the numbers. The sample size again is 8. If you count them, got 1, 2, 3, 4, 5, 6, 7, 8. So you're going to add all of the numbers and then divide it by 8. And that's how I get the mean. Okay. And the mean will be 2.5. As you can see here, if I can ask you what is the typical value here, you can see the typical value will be 2. 2 is the number that will repeat the most, is a typical value. Okay. If I have to do the bar for it, just on the side, and I want to put let me do a small table for it so I can do it quickly. I put 2. I mean, it's gonna be 1, 2, and then I'll be 3, 4, and then 5. Okay, something like that. For 1, the frequency for 1 is just 1. 1 appear 1 time. 2 appear 4 times. 3 appear 2 times. 0 appear 0. I mean 4 appear 0 time, and 5 appear 1 times. So if I do the bar graph for it, this is going to be 1, and that's going to be 2. That's going to be 3, 4, 5. I can do a histogram if I want to, but just to make do the idea. So for 1, you appear only 1 time. So suppose this is the highest one is 4. This is going to be 2. This is 0, and then 4. So 1 appear 1 time. Let's do something like that. This is 1. And then 2 appear 4 times. So that's me going to go all the way to the top. You can go like this and go like that. Again, I'm doing handwriting. It's not really perfect. I'm trying my best, okay? Then 3 appear twice. And then 4 appear 0 times, so there is no 4. And then 5 appear 1 time. Okay? As you can see, just like we had earlier, the mean, if you do the mean for that, the mean is 2.5. 2.5 is somewhere around here. Okay, this is 2.5. As you can see, 2.5 is on the right side of the typical value. And if you notice also, this one is barely like a or right is Q. Okay, and probably 5 might be a number, the number 5 might be outlier. I mean, pulling the mean toward itself. Okay, so the mean is on the right side. This is the mean X bar is on the right side of the typical value. Okay, that's a question. And the test we need to do the graph. The test is based just like you had the homework. Okay, just like you have them. So far in the homework, they don't actually do the graph. And then I do have on the test, this is not going to be multiple choice. The test not going to be multiple choice. You're going to have to do some work. Okay, and there's going to be a review. And from the review, it's going to give you an idea of what to expect on the test. Okay, if you do have to do the graph, you will be given the tools to do so. Okay, so make sure you do the homework section. Again, that's something I want to point out to you guys about the homework. And the homework is from Pearson. That means they will give you things that is not really the idea of TCC. Okay, but that means that you might have more stuff in the homework, and so now you might not have everything that you need in the homework section. It's good to work them out. It helps you understand the material, but it's also best, what you need to do is also best to get ready by looking at the review for the test. Okay, what I'm going to be doing from now on, beginning today, what I'll do, I'll try to give you the review for the test like a few weeks before, so you know what to expect in the test. What do you guys think? That way you don't battle everywhere trying to figure out what's going to be on the test, so you know what probably the idea was what to expect on the test. So because Pearson is like, I have too much ideas, which doesn't available. So tonight, what I'm going to be doing, I'm going to put the review available for you. You can have a review for in PDF file, and also a review that is on a video review. Okay, so what I'll do that each time we have the new section available. I'll make the same than the review, not the test, but the review for this available for you. So I'm going to do that tonight so you can have an idea of what to expect, so you don't be too clueless. Okay. So Pearson is doing a really good job on that. We just use the system. It helps the students, but not fully. You're not gonna get the exam question type exam really in Pearson. They're gonna give you more ideas. Okay. All right then. So after that, I'll talk about the mean, and also you're welcome to ask me questions from the review. Okay. Whenever it's time for the exam, you can ask me a question, but for the review exam, you're welcome to ask me, and then before the test. All right. Okay, so talking about the standard deviation again. The standard deviation is, we use the little symbol S, just like I told you earlier, is a measure of spread. Again, the measure of spread means that how far each value falls away from the mean. Okay, that's what it means. So it represents, again, it represents a typical distance from the mean of the observation. So every value, so this is my idea, just repeating. So this one like to repeat itself. We talked about this one before, okay? So now, so that's something else we need to enter it. So whenever you're talking about standard deviation, we also call something called variance. The variance is the square of the standard deviation. That's mean if you're talking about, let's just read, this is the standard deviation, okay? So you got two things. You got something called a standard deviation right here. This with standard deviation, and you're gonna put variance right here. The standard deviation is gonna be always letter S, okay? The variance will be S squared. Okay, that's the definition. That's why I said the square of the standard deviation is S squared. Okay, if this is for a sample, just in case you will talk about in the future. In the future, if you have population, the standard deviation will be sigma, and then the variance will be sigma squared. Okay, just something to remember. Okay, so any questions so far? No questions. So remember that thing about variance. So this is a new concept here, the variance. And then we already spoke about this three concept earlier. Is another way of saying the same thing. Now, this is an example. They say that, can you tell which one has the highest standard deviation and which one has the lowest standard deviation? Something like that. Can we tell that here? Look at by looking at the picture. So is it graph A, B, or C? Which one has the highest standard deviation by just looking at it? Remember, we talk about standard deviation whenever we have the most observations for a given set. Just by curiosity, can you just figure out what that one can be? Is it A or B? Just find it. Let's find the one that have the lowest standard deviation. Nobody see anything? Okay, so that's okay. So here, let's look over here. Look at C. The typical value is right here. Not all of the numbers have this highest, there's not that much observation. We got some low observation on the left side and some low observation on the right side. I think in that case, this one we have the smallest value because it got some low values. Okay, but over there here on B, we have everything look really high. So therefore, the mean also be high. But there's a problem. It's also the standard deviation is also the distance how far the value fell away from the mean. It seems like in that one and B, the value might be close to the mean. All of them might be very close to the mean because all of them kind of have the same type of variation. While A, I cannot say anything right now about B. It's hard to say it about B. So let's look at A first, add it to it. Here we have two large observations on the left and the right side. In some small observation in the middle. It seems like this one, and also if you look at the mean, some value will be like really far away from the mean as well. So suppose this is the mean like this, the value will not be close to it. Okay, the value will be like far away. Let's put x1 and then x2, something like that. x2. Here, the value will be closer to the mean, really close. x2 right here, and then x1 over there. That means this is a bit closer, x1. While this one is kind of like some smaller value. Okay, we got x1 right here, and x bar, and x2. I mean, how far they are from each other. So, but because he got some bottom house the smallest, we can say this one has the smallest standard deviation compared to A. Okay, so I can say that because the standard deviation is on B kind of closer to each other. So by just analogy, I can say this one is the smallest will be this one, and then the highest will be this one. That'll be the highest one. And then B by default will come in the middle. Because the variation of all the data are kind of the same. That means they're gonna be really close to the mean, making the standard deviation for it kind of smaller compared to A. While A has a better variation. I know this is not the typical problem we want to work on, but that's the idea behind it, okay? So the solution will be smallest to highest will be C, B, A, okay? So you can have more example like this in the quiz, not the quiz, I'm sorry, inside the homework section, okay? Any question about it? I think I see no. Okay then. Now, what we're gonna be doing now is to put together the standard deviation and the mean together, okay? So we're gonna put them together. I just did it quickly while for you. When I did the picture right here, this one is the standard deviation. Let me just put it right here. I'm gonna use a different color. Where's my color? Wait. So this is gonna be the standard deviation right here on average. Okay, again, the standard deviation is how far each data that value fall away from. That's not a 5, that's an S. And here also be the standard deviation. Here will be the standard deviation, okay? This is the relationship between standard deviation, is how far the value fall away from the mean, okay? So I'm not sure if you guys understand what I'm talking about. It means, for example, for this, in this case, let's talk about that case, which is the most typical one. You're gonna have x1, for example, will be equal, because it's a smaller one, will be equal like x bar take away s. Or you can say x2 is equal to x bar plus s, something like that, because s is the distance from x1 to x bar. And also at the same time, s is the distance from x2 to x bar. It means that also x2 is bigger than x1. I know if you guys see what I'm talking about, right? It means also that x2 is bigger than x1, because x2 will be on the right side of x bar and x1 will be on the left side. That's why one is negative, the other one is positive. Are you guys following me? Are you guys following me? Yes or no? So that's my Cortana talking. I asked the question to you guys, not to my computer. Okay, so my computer probably is listening to me teaching as well, but you cannot get statistic right now. So that's mean I can say on average, that's mean any value that you have, you're gonna say this is gonna be x bar plus or minus s. Okay, an average, because s is the average distance. You can say average distance of the data value to the mean. Of the data value to the mean. There'll be some nuance, because what I just give you is just a general formula. What we'll have to do, because of some of the things that happen, we'll have to put a specific value. We're gonna be talking about it in the future. So that's how we put something like this. Instead of just saying x is equal plus or minus s, this is the whole formula we're gonna be talking about in the future. I'm gonna write it down for you right now. In fact, the right formula goes like this. You're gonna say x bar plus or minus, and then z, which is a constant value, times s. Okay, so time s. We're gonna be talking about in the future. This is a constant value. Constant value. we're going to be talking about in the future. And then that Z constant value is called a Z score. Okay, I said it's constant. It's not really constant, it's a variable as well. But for the set, you're gonna need it. It has to be a specific number for it to work it out. You can find it as well. So I don't want to use the term constant just to avoid people getting confused. Is a value, numerical value. Let's put numerical value instead. Called Z score. So that way people have it being confused. So yeah, this is how they're confusing. It's a numerical value called a Z score. Okay. So that's what we're going to be talking about. So this is the relationship between X bar and the standard deviation. So again, X bar is the mean, and S is how far each value is to the mean. It's an average distance, okay, from each value to the mean. We'll have to use a constant Z, a numerical value Z, just in case the value will be like, the value can be twice the standard deviation away from the mean, or 3 times the standard deviation away from the mean, etc. We're going to be talking about that soon. Okay, let me keep working. So, for example, this is an example here. They say in San Francisco, the mean height temperature is 65. This is the mean X bar. It will be 65. And then degree and the standard deviation is 8. That's mean letter S is equal to 8. And Provo, the mean is 67. The standard deviation is 21. So here, that's another type of that is a different place. Okay. So I will call this one instead. Okay, let's talk about it. So this one say is a high temperature of 52 where and San Francisco and Provo. Okay, this one is also X bar for the city called Provo, which is 67. And the standard deviation here is 21. We would like to know whether is where is more where in San Francisco. Well, which one is the where on? So that's what I want to know. So looking at the value is kind of hard to grab. But look at what we can do here. So the temperature is higher. It's a temperature of 52 high where in San Francisco. Notice that 52 itself is a number less than 65 and 67. Okay. So what we're going to be doing, because 52 is less than that. So what we're going to be doing is, that means 52 is on the left side of 67. So let's do it for San Francisco. Okay, let's do it for San Francisco. So what I'm going to be doing, I'm going to find the smallest value for San Francisco. Okay, so what I'll do the following thing. So here, San Francisco, if you do 65, take away 8, just like we did earlier, this is X bar minus S. It gives you 57. This one is also X bar minus S. This one is 46. Okay? See that? One is 46, one is 57. So look at it here. 52, if you look at 52, 52 is in the range for Provo. That means if you have the smallest value over here, if you look at the distance of 46 to 67, and then 52 is somewhere around here. Okay? But if you look at for San Francisco, this is 57 all the way to 65. 52 is not even the range. 52 fall outside of the range. Okay, so this is the standard deviation right here. So based on that observation, where do you think it is where? Is it in San Francisco or in Provo? Anybody?
San Francisco.
San Francisco, because it doesn't fall in the range for San Francisco. Thank you very much. Okay, so it's gonna be the rarest temperature will be San Francisco. Thank you very much, San Francisco. Okay, because it doesn't fall in the range. Okay, so it falls outside of the range. Now, there are ways to calculate standard deviation. If I have time, I can show you some of the program, but you guys are allowed to use the scientific calculator. Usually I have the scientific calculator on my computer, but for some reason, I'm not able to get the software again, which is the TI-83. I still have it here, but I'm trying to see if I can get it back. But I do have some of the program. I can use Excel to show a couple of stuff to give an idea. And also can use Start This or Start Crunch, but I have started. But if I have time today, I can show you the idea behind the means and standard deviation and the bar graph and histogram. But I'm gonna have to keep going just in case. Okay, I'm gonna have to keep going and then we'll come back to it if you have time. So what we need to talk about it again, just how we talked earlier, this one is gonna be talking about what is unusual and something called the empirical rule and the z-scores. Okay, so this is what happened. Whenever you have the mean, okay, just like I told you earlier when I did the graph for you, I did X bar like this, okay? And I say something like this, and I put SY here and S over there, okay? Okay? I did say I put a value of Z. So here, as you can see, the first one say 1, 2, 3. We got 1 over here, then you got 2, you got 3. This I will call the Z value. This is how I call it the Z scores. So here the Z will be, that's a Z, okay? Either it can be 1, it can be 2, or it can be 3. Okay? So this is for Z is equal to 1. The value is like this. Now for Z is equal to 2, then you got a bigger, shape. With my pen, the graph is a bit bigger, like this, X bar, and then like this, X bar. This is 2 times S. This is 2 times S. Okay, to get the X1 and X2. Then you got Z is equal to 3. This one kind of way bigger. This is X bar. And then this is 3S. And then that's what I'm trying to express here to you by doing this way. I know it can kind of look weird, but that's what I'm trying to explain to you. This is what it means. It means that whenever you have a data, if you are given the data set, 68% of the data will fall within one standard deviation of the mean. I mean, between 60% will fall within one standard deviation of the mean. Okay? So I'm gonna repeat it for you again, okay? And then 95% will fall within 2 standard deviation of the mean. And then this one say almost all. I'm gonna put a number to it. I'm gonna say this is it's 97.5. It's gonna be no, 97.5. 2.5, yeah, that'll be don't look at this one. This one will be 97.5%, which is almost of the data will fall within 3 standard deviations of the mean. Now that's one on our last one from here to there, that'll be 100%. Okay. So from here, from that black stick to the other black stick, that's 100%. Okay. So that is what I'm doing now right now, because I'm going to be talking about something that is important for you. So if you don't understand the graph, So once, okay, let me just do it right here, Say this is approximately 68% of the observation will fall within one standard, roughly two-thirds will be within one standard deviation of the mean. That's mean if you are doing interval thing like this, that's mean this is gonna be X bar minus S, X bar plus S, that'll be 68%. Or I can say X bar plus or minus S. That'll be 68% of the observations will fall there. Okay. Then the next one will be 95% will fall within two standard deviation. You can say X bar minus 2 times S, X bar plus 2 times S. 98% of the data will fall there. Okay, I can say X bar plus or minus 2S. By the way, this is called usual value. If you fall there, this is called usual. I will talk about it again. This is usual. If anything went forward within two standard deviation, it's called usual. And then the rest one will be X bar plus or minus 3S. Okay. And the rest will be 100%. But we just want to talk about this thing right here. So here I would like to put 90, nearly all of the observation will be 97.5%. Okay, so that's what it is. That's the exact number for it. Any questions so far? We have a few more slides left. So let's keep working. This is an example. This one said the mean body weight for a woman between 18 and 25 years old is about 134 pounds. The standard deviation is 26 pounds. So we assume that we have a bear shape. They say mound shape, this is something as bear shape. So what do we have here? So what you're gonna be doing, you're gonna do, because the standard deviation is 26, you're gonna say X bar minus 26, minus standard deviation, and X bar plus the standard deviation, because they say this one is the mound shape, okay, it's between, it's okay, and X bar plus S, okay? One give you 108, the other one give you 160, okay? So I don't expect less now because, so here, we notice that 134 is within that range. If you do 108 and then all the way to 160, and the mean is about what? 134. Notice that, what is it again? They said when they asked them, okay, there was no question. There was no question. So we can say about 68% will fall within that group. This is about 68% of data, okay? But they don't have any questions. So I thought they had a question. So if you do the same thing, this is 60%, okay? For 2, you're gonna say about 95% will fall within 82 and 186. Okay, so this is 2 standard deviation. Let's do the bar again. I'm gonna have to make this one a bit smaller so you can see. So right here, this is 82. This is the 134. And this one will be 186. So this one will represent 95% of the data set, okay? And almost all will be between 56 and 212. This one, I will get it, you're gonna do, instead of putting 2, you're gonna put 3. I think it makes sense, right? You're gonna say 134 minus 3 times 26. That's gonna give you 56. Or 134 plus 3 times 26. That's going to give you 212. Okay, for your class, you can say almost, or you can say 97.5%, 97.5% fall within 56 and 1 to 12. Any questions? Okay. Somebody ask a question? So I'm going to tell you about based on two standard deviation, based on the formula I just showed you earlier. Just show it to you again. Right here. Right here. See, there's a 2 right here. That's why I'm going to tell you about 2. And that's why I'm going to tell you about 3. Okay, 1 is 1. Okay, that's why that's what I meant. That 2 over here and that 2 over there. Then I will present over there for you as well. Okay, so you have to meet here by 2. Okay, you're welcome. So where was I? Okay, so I'm gonna skip that example. This is kind of the same idea. So if I have time, I'll go back to it. That's another type of exam. Example, but I'll go back to it if I have time. So again, another example, the same thing again. Okay, so now this is something called usual value. So with the usual value, I think I'll come back to this one too. Give it to the elimination. Okay. So the trouble with pick I validate data is unusual. So this is what happened. If you have a data value, okay, just think it that way. Okay, and then this is X bar. And then this is gonna be, this is the line, this one here is gonna be X bar minus, plus 2S. This one over there is X bar minus 2S. So whenever data fall in that range, they are called usual. So that means if a number have a z-score of 2, and a number with a z-score of 2 is usual. When z is equal to 2, hold on, try to get my pen again back here. Okay, let me just give another way to do the same concept. Or you can have something like this. If you have a bracket, this is going to be X bar minus 2S, X bar plus 2S. Anything in that interval is usual. Usual values. Anything beyond that is rare. Okay, if you fall beyond that, if you go on the outside, it's become rare. Let's put it over here. Anything beyond that, that's rare. Okay, this is rare. Rare or not usual. If you fall beyond that interval, you become rare. So that case here, we have the z-score to be either plus or minus, the z-score around to be around 2. Okay. So I'll go back to this little tweet example if I do have time. Okay, but we'll largely focus on the z-score before I talk about this thing right here. So you can listen to the z-score. What is the z-score? Again, the z-score is a number of standard deviation, okay, a value far away from the mean. Okay, another way is to measure the number of standard deviation, the value is from the mean. This is the same value that you saw earlier. Whenever you have like X bar plus or minus 1 S, here Z is equal to 1, or X bar plus or minus 2S. In this case, Z is equal to 2, and X bar plus or minus 3s, in which this case z is equal to 3, okay? But we do have other z's. What are some other value you not exactly on 2 or 3? So this is where you come, this is a new formula that come here that is very important for you to understand. Okay, this one, whenever you talk about them, they are for standard units. Okay, the z-score is used to compare value measured in different units such as feet and millimeters. That's mean if I have the z-score, I'm able to compare anything from a different unit. Okay, that's just, these are just benefits of the of this z-score. But let me talk about the formula that is very important. This is the formula that we use for it. So the formula is always z is equal to x minus x bar is over s. This formula is not new. We talked about it before. If you can take, let's talk about it a little bit. Are there like, you don't have to do this. I mean, this is just, you just have to write it down, but other we come up with that formula. Let me show you something. Whenever you had the formula earlier as such like this, where's my pen? We had z, okay? I mean not z, x bar plus or minus zs, right? Okay, suppose you say this is equal to x. I'm gonna take one of them, okay? For any value. Let's say for example, x is equal to x bar plus zs times s, right? Now I can solve for let's solve for z. So let's assume z is the unknown. Okay, so what I'll do, I will say that take away x bar on both sides. We have x minus x bar is equal to z times s. Then you're gonna be solving for z. You're gonna get x minus x bar is equal to z times s, divide both sides by z. The z goes over on the first side. I'm sorry, not z. Divide both sides by s. Because I'm solving for z. The s goes away on the first side, then therefore you're gonna have x minus x bar is over s is equal to z. So that's how I got that formula here. So that's why I say it's not new. Again, the z is the number of standard deviation of value is away from the mean. Again, z is the number of standard deviation of value far away from is away from the mean. So we call the z-score, number of standard deviation. Let's put S D, number of standard deviation value of value. Sorry about my handwriting. Let me just do it again one more time. A value x is away from the mean, something like that, from x bar. Okay, so let's look at an example. This one, you don't need to memorize it. You just have to write a little note. Here, for example, they say that the mean price for a loaf of bread is $3.12, and the standard deviation is 0.89. Okay, cents. 89 cents. Find the z-score for a loaf of bread that costs $2. Now, they give it the bread cost is $2. Okay, therefore, let me use a different color. This is what we have. This one is x bar. That's the average, 3.12. This one is S, 0.89. Now this is X. So it means, this is the question. On average, $2 is about 89 cents away from $2.12. That's what it means on average. But the work we know how many standard deviation X is away from the mean, or I mean, what's the Z-score? So what you do, you're gonna say Z for the loaf. Okay, so let's just answer with the machine. It's right here. So you're gonna do $2, gonna be X minus X bar over 0.89, it give you negative 0.26. What does that mean? It means that $2 is 1.26 standard deviation below X bar. Okay, that's mean $2 is 1.26 standard deviation below 3.12. That's what it means. If it was positive value, I would say above. If it's negative, I would say below. Okay, if I on the side, if I want to have how far the mean is away from itself, that would be something different. I would say, for example, if I add an extra example, suppose I say X is equal to 3.12 as well. How far is 3.12, or how many standard deviation is X to itself, to the mean, okay, to the mean. What I'll do, Z is equal to 3.12 minus 3.12 divided by 0.89. That's going to give you 0 over 0.89. That's going to give you 0 again. That's mean 3.12 is 0 standard deviation. For 0, there is no such thing as either above or below. I'm going to say because the number is 0. So now I'm going to say, I would say in that case, away from X bar. That's mean 3.12 is the mean. Okay, it's 0 units away from it. It always 0. People like to say units sometimes. If you don't want to say standard deviation, some people like to say units away from the mean. Okay, so that's mean is about 0 standard deviation away from. That's mean the X bar is the mean itself. I mean, X is also the mean here. Another example that I got for you here. Yeah, this is about negative consequences, but you need to understand the interpretation, okay? Here, this is an example here. Want to know which one is more unusual? Okay. So they say that which one, what is more unusual? A value of 0.26 from a distribution with mean 0.37 is an elevation of 103, or 45 from a distribution with a mean of 38 and now division 4. Here, we got two type of value. For the first one, we got X bar, we got X is equal to 0.26. We want to know whether 0.26 is unusual. With X bar is equal to 0.37, and S is equal to 0.03. And the next value is over here. We have, this is X is equal to 45. X bar is 38. And then standard deviation is 4. Okay, we're gonna, which one is more unusual? So you can use the same formula again. Okay, so I don't want to, whenever I put all the answer, I want to save time. So here for 0.26, it say that it's gonna be 0.26 minus 0.37 over 0.03, okay, is equal to negative 0.367. Okay. So I don't know if you guys understand the idea. So to get the Z for that guy, you do 0.26, which is X, take away 0.37, divided by 0.0. This gives it negative 3.67. Okay. And also, if you do here, this one gives you 1.75. Okay, if you do 45. But there's something I want to remind you before I go. Let's go back here a little bit to that example that we did earlier about the usual and unusual. I was going to talk about it again. Where are you? That example here. I think I cannot see my notes there. One moment. So let's see. And pick our values, the score. Here. Remember when I said that here, z-score, the z need to be 2, okay? There's something I would like to add to it. We can also do an interval for z values as well. I can say anything between 2 and 2, I mean negative 2 and positive 2 will also be usual. You can do the same thing as well. Where did I got the 2 and negative 2 from? Let me just show it to you. Let me just put this. Where did I got those 2 negative 2 from? So here is usual. Why is this is usual? Negative 2 come from here. This is negative 2. The positive 2 come from there. So you can do the same thing also for z-score. Anything with a z-score between negative 2 and positive 2 will be usual. Okay, anything between negative 2 and positive 2, z-score will be usual. This is whenever you do for the z-score. So let's look at for carefully here, the example that we just did. Why is my cursor thing? So let's the example we just did right here. Which of the two values you think is unusual? Remember, we have z like this for usual value. This is z. Okay. Then you got negative, positive 2, and then negative 2. By the way, z will be 0 in that case because it's the center. Okay. So which value for this is usual? For there. Is it negative 2.67 or 1.75? We shouldn't fall in that range for the z. I'm asking a question. I would like to have an answer. We have like 2 minutes left. Which one is we think fall in that range or interval? Is it negative 2.67 or 1.675?
1.75.
That's mean 1.7 will be more usual. Okay, thank you very much. So this is the value that will be there. Okay, so let's see. So the value of 0.7 is more usual. I'm sorry, the value of 0.26 is more unusual since it has a z-score that is farther from 0. So that's trying to say that just if you think about what I told you, negative 2 and 2, that'll be easy. So 0 for 0.26 is far away from that range. Therefore, that'll be unusual. Okay. So the one that is usual will be what is 45. So the question was asking about the unusual. Okay, more unusual will be 0.26. Okay, so I'm gonna stop here. If you have any questions, please welcome to stay. I'm gonna stop the recording for me. And once I finish this note, just like the other one, I will put the notes online for you on Pearson.